Hi mathletes, we are graphing quadratic functions. At the end of this lesson, you will be able to graph quadratic functions in vertex form.
So vertex form of a quadratic function, you can cross off value if your paper has that. That is a typo. Looks like this, and it does remind us of an absolute value function. The only thing different between an absolute value function and a quadratic function is the bars are replaced by parentheses, and you add the squared here to represent the quadratic function. But the a, h, and k are the same, and they behave in almost the same way. So the HK is the vertex, and they behave exactly the same as they did when we were looking at absolute value functions. And the A value tells us two things, and basically the same thing. So the A value tells us something about the rate of change, so where we put those values. It's not exactly slope when we're talking about quadratics, so that's why I'm using the phrase rate of change. And it tells us the direction. And this behaves exactly the same as with absolute value. So if it is positive, you are going to say that the graph opens up. If it is negative, you say that the graph opens down. And from our opener, we know that these are U-shapes. So that's what we're talking about when we're saying up and down. So no straight edge for quadratics. So we're going to look at our examples now, and we're going to start with this first equation, and we're going to start with the vertex, which are these numbers right here. Looking at your equation, you have it written at the top of your page. I've written it here. Recall that this negative right here means opposite. It's always going to indicate that in an equation, in a form, because when you subtract something in the form, it's going to change the sign. And on the outside, the k value is going to stay the same value for the y. So our vertex is always an ordered pair, and we're going to start with that. What's with the x goes in the x spot of the vertex. We often call that h because that's how it's put in the equation. And I see a -3 in my equation right here, and that means I'm going to have a +3 in the x spot of my vertex. We look outside of our parentheses to see the y spot of our vertex, and we see a +1 there, which means I'm going to have a +1 in the y spot of my vertex. And we often call that k because that's how it's typically used in our form. Now we're going to look at the a value, that number in front of our parentheses. We don't have a number here. 1 is that placeholder because 1 times anything stays itself. It doesn't change the value. So my a value is 1. You can think of that also like 1/1, like the slope. And the difference is you don't keep going. Like absolute value, you keep using that same a value to make your many, many points. For quadratic, we only can do the first step that way, and I'll tell you what I mean. So the first thing we do is we always plot the vertex. That's step number 1, so 3, 1. We plot that vertex. And then we're going to use our step, and up 1 over 1 in both directions is that first step. The third step that we found in our opener always comes out to be 3 times our a value. So 3 times 1 is 3. And again, we can think of that over 1. That means our next step. So I'm going to go up 3 to the right 1, and then up 3 to the right 1 there. And then we're going to connect these points with a smooth curve. We would have to do some more work to figure out the next points. So we're going to just do 5 points for a parabola, just like we did 5 points for an absolute value. We're going to do the same thing for example 2. We're going to start by finding the vertex. So the x spot of our vertex, I see +1. That means there's going to be a -1 in my ordered pair. And outside, I don't see anything here. Now, that means it's like adding 0. There's nothing there, so we're going to put 0 because anything plus 0, if you're adding or subtracting, it's 0. That's the placeholder. And my vertex is -1, 0. And that looks like right here on your graph. So always start by plotting that vertex. So let's look at our A value, and that's a negative. That tells us right away that our U shape is going down. We forgot to do that in number 1. It was positive, so it was going up, which we graphed it correctly. So that -2 is our A value, and we can put that over 1. So we're going to go down 2 to the right 1 and down 2 to the left 1. That's our first step. So our graph is stretched out a little bit. And then we're going to do -2 times 3 for our 3a, and that's -6, and we can think of that over 1. And so now from here, I'm going to go down 1, 2, 3, 4, 5, 6, and over 1. You could do the over 1 first if you want. And then down 6 and over 1 here. And then connect those with the curve. I sometimes like to do the middle part first to get my curve. Looking at the third example, we can see that there's no parentheses. There's nothing in with x. That means there's a 0 in that placeholder. For the y value, you can see that there is a +1. We do not switch the sign for the y. And then we look at the a value. Our a value just has a negative here. That means it's -1. So let's plot our point 0, 1. That is going to be up 1. And then we have a negative a value, so we're opening down. That means we're going to go down 1 to the right 1 and down 1 to the left 1. And then for the next step, we are going to take that, we're going to do 3 times -1, so that's -3, and we can think of that over 1. So we're going to go from that point down 3 over 1, down 3 over 1. And so this is kind of that standard parent function shape. So make that nice curve to go through those 5 points. Let's take a look at number 4. In our parentheses, we see -2. That means our vertex is +2. On the outside, we see -4. That means it stays -4. So the point we plot is 2, -4. That's right here. We look at our a value, and we see a 3. So that's positive, so we're opening up. We're going to go up 3 over 1, up 3, left 1 for our 2 points. And now we're going to do 3 times 3, so 3 times our a value, and we get 9. So 9 over 1 to plot from that point. So up 1, 2, 3, 4, 5, 6, 7, 8, 9 over 1. And then we're going to go, we go up 9 over 1 from here. And make your curve. This one is much more narrow than the other one, and that has to do with that leading coefficient, that a value of 3. So we're going to summarize here. You can screenshot this page if you want to have this for your notes. Here's our general equation. These are the placeholders that we're looking for. This negative is always going to indicate opposite. So in the ordered pair, you see that you'll have the opposite. So in this example, I have a +4 inside my parentheses. That means I have a -4 in for the vertex. I talk about that right here. For the k value, it's the same, plus k, and so that's the y coordinate of the vertex. So in this example, I see a +5. That means I have a +5 right here, and so that's plotted right here. Left 4, up 5, that is my vertex. And the a value, the number on the outside of our parentheses, that tells us the direction, opening up or down. So in this example, it's -3. That means I'm opening down because of that negative. And it also talks about our slope or rate of change. And the first part of it is the same as absolute value. So whatever number you see here, that's your first step. That's going to be -3 over 1. That means, and it's negative in this case, so that's down 3, right 1. And I'm going to put that point right here in either direction. So down 3, right 1, down 3, left 1. That's your first point. Now for quadratic functions, because the rate of change is not constant, is changing at an increasing rate or a decreasing rate, you are going to have a different step. And we found out in our exploration that it's 3 times the A value for the second step. And that's enough to get the shape that I'm going to be looking for. So 3 times -1 in this, 3 times -3, our A value is -3, gives us -9. And so from that point, you go down 9 to the right 1. And then from this point, down 9 to the left 1. And so you should have a symmetric graph. As if there's a mirror here along this center line. Refer back to this slide if you have any questions. This really summarizes everything you need to know about graphing quadratic functions.